Okay, this is CCNA3 version 7, and we're going to look at lab 6.6.7, or more correctly, packet tracer 6.6.7. We're doing port address translation. So we're going to start out right here with this here router 1. And we want to automatically and dynamically assign IP addresses to PC1 through laptop 2 here. And to do that, I'm going to start out by clicking on the router. And it automatically logs us into the command line interface. All right. Enable it and get into global configuration. Hold on. All right, so the way we identify the traffic that we want to translate is with an access list. And in this case, Ella, come back in like 15 minutes. The way we're going to identify this is by saying that everything on this major network is going, or this /16 is something that we're interested in. And both of these networks are in that same /16, so we're including both of them by doing this. Put in our wildcard mask for a /16, like that. Great, and that's it. That's all we need to be able to identify the traffic to be natted. Then we need to create a dynamic NAT statement. So this is kind of long. We haven't made the pool yet, the NAT pool. In this case, we're going to have more than one public IP address. So we can put in the NAT pool name, even though we haven't created the NAT pool yet. And define it with this 209.165.200.233. So that's the beginning address in our pool to our final address. And you'll notice that there's only a couple of IP addresses there. So what that does, or what that will be, is that it'll increase the number of clients that we can NAT for. When you do port address translation, you use port numbers to differentiate the clients that are inside. And this way, by adding more than one IP address, we can increase the number, like, into the hundreds of thousands. So the network that we have to work with is /30 network, which is why we only have 2 addresses. All right, so what we're saying is that we have this pool of addresses right there, and it's they're the IP addresses that it's every IP address in this /30 that we were assigned, and that's going to be the public facing part of our NAT address translation. All right, now we apply all that stuff that we just did. So in this case, we're saying that we're identifying the traffic to be natted with this access list right here, source list 1. And this is the stuff that's inside of our network is identified with that access list. The pool, we just named it any name or any pool name. And we use, you can see here that we could just leave it at that. And then we would be able to do we do address translation for only 2 clients at a time, which is insufficient. Well, actually, it would be sufficient for this. I'm sorry, it would not be sufficient because there's 2 networks and each network has 2 clients. So you'd only be able to provide access for half the clients. So we use the overload statement, and that's what makes it port address translation, so that we can then use the port numbers to increase the quantity of devices that we can do NAT for. So for all of these guys right here, the inside network is everything that we're responsible for, and the outside network is everything that we're not responsible for. So there's 2 divisions. We have inside and outside. We're only concerned with inside. Internet can do whatever it wants. And then there's local, which is the address that we have inside of our network. And then there's global, which is the address that the rest of the world sees our network as. So we're only concerned with inside local and inside global, even though there are cases where you might want to do network address translation in the other direction as well. All right, so we apply said network address translation. Our outgoing interface, you can see here, is serial 010. So we'll do that. And that's going to be outside our network. You have to put a T in outside for it to work. And then interface G000 IPNAT inside. So our 2 gigabit Ethernet interfaces are going to be our inside network. So we're translating from these addresses into this outside address. And if we look into this, we'll do this and we'll do copy run start. And then if we do show IPNAT translations, right now we're not translating for anything because we haven't sent any traffic to translate. Doesn't have us anything. We'll do some pings, and it'll get us some NAT translations. Dun, dun, dun. Go. One more. And look at that. All right. So, like I was saying, we have the inside addresses are the ones we're concerned about. Outside of our network, we're not concerned about it. For us, this is the internet, and we don't control this. But our you notice that our inside global is using our global IP address with port number 1024. Oh, you really have to make this big. And the inside local is just our private IP address space 172.16.10.11, and Apparently it's port number 1. It's weird. I guess because it's ICMP, it's layer 3, and there's no layer 4 port number, so they just default it to 1. Interesting. And then for this one, we got port number 1 for our global, and that's our inside private IP address, or our local private IP address. So we're going from this, we're translating from this local to the global, and then back again in order to be able to get our ping. So this address outside, you notice, is always the same, and it's the server 1 here. So yeah, we don't control stuff. In this case, we don't control this outside network, so we're not concerned about that. So draw a line right there and just don't care about that part. So we're only interested with inside addresses in this case. All right, and that's router 1. Oh, it does. Actually, it tells us to use the web browser rather than pinging. If we do that, then we would see port numbers other than 1, which is probably better. All right, so next up, we're doing router 2 over here. And this time, we only have 1 global IP address. And the configuration gets considerably simpler. This is what you would have at home, and probably what you would have in a small to medium-sized company, because you're not likely to get over like 20,000 users. And it's less expensive. All right, so let's enable. And the first thing we want to do is we want to make an ACL. So we've got 172.17 is our /16 network. So if we just do IP access list to tell us what number to use, so that it gives us credit, ACL2. Oh, it even tells us what network to do it on. But we can see that if we do 172.17, that includes every client in our network. And put in the wildcard mask. Oh, is that? Permit. All right. All right, we're doing this wrong. Well, the access list. Oh, I didn't put the number. I looked up the number and then I didn't put it in. Okay. The access list 2. Just doing IP, right? IP. Ugh. Great. It's not IP access list. Sorry. access list to and permit no, we don't. Oh, because it's a standard access list, we don't have to do that. All right, then we need to match our ten dot oops, 0.0 0.255, and that's good. Okay. Yeah, so the show commands show IP access list, and I was putting that in there for the configuration command. And I put a protocol. Wasn't necessary since this is a standard access list. Great. So we've got our access list. We know what type of traffic we want to permit, or that we want to do the translation for. So then we want to do the that translation itself, and it's going to be simple. We're just going to say that use the IP address that's on serial 011 and use port address translation. So assign or do the address translation using port numbers. All right, and command for that, just typing at inside source list 2, which is the access list that we just did, and the interface serial 0/1/1 overload. Then we have to decide what's inside and what's outside. We know that serial 011 is outside, so interface serial 0/1/1 outside, and interface interesting gigabit something it's 000 and 001. There we go. Okay. Notice that we didn't have to create an address pool. Since we only have one address, we just identify the interface, and it'll use the address on that interface. And we only have 2 interfaces, so that should be it. This time we'll do the browser so that we can get some better port numbers. Even though it doesn't say, we should just be in the habit of doing the copy run start at the end. And let's access some services. Up on this, get on a web browser, do 209.165.201.5. So which is our server 1. And then if we look, we'll do one more. PC4. We'll do try to access that web server again. Okay. So we know that those requests are going to go to port 80, but they could be coming from any port. If we look on here, we do show IPNAT translations. You'll notice that So our inside network, which is the only part that we're concerned about, globally, we're using the IP on serial 011, 209.165.200.128. Oh, that's the network, sorry. So out of that network, .130 is the address on 011. And we're using port number 1024. And then the local address that's in our local network is going to, it's going to keep its same port number. So in both cases, and this is just kind of a coincidence, the devices decided to use 1025 for the port number, but you'll notice the destination port number is 80, and the address outside of the network, we're not changing it at all. We're not doing anything with it, so so it stays the same. And Ethernet translations. We get statistics. Show IP NAT statistics. So why doesn't it show? Well, it does show 2 dynamic. It's a weird question. I mean, originally, so before we would have done any of this, it wouldn't show any because the translations hadn't been made. And we looked at that. And it says, why doesn't R2 list any dynamic mappings? Oh, dynamic mappings here at the end. Okay. Let's see if R1 does. That could be something to do with having an NAT pool, but I don't know. Show IP NAT statistics. Yeah, since we don't have an NAT pool on R2, it's not showing any dynamic mappings. There's only one address. Okay, so we take a look at this guy here. Check results. Congratulations, we're at 100%. And that's lab 6.6.7.